Hi, in this video you are going to learn or you are going to get a detailed explanation of each and every part of the EDA playground, that why this part is used or what is the need of this part, or after using this part what will happen in the EDA playground. Each and everything will be discussed in this video only. Okay, so this video is the detailed explanation about each and every part or each and every setup of the EDA playground. So without wasting any time, let's begin. So at the first you have to know what is the full form of EDA playground. The full form of EDA playground or the full form of EDA is electronic design automation, and the extra word is present as playground. Okay, that means electronic design automation playground. Now what is EDA? This is the category of all software tools used to design and test electronic system like computer chips, like CPUs, FPGAs. For this EDA playground is used. Now the playground, this name was chosen because it's a place where you can play, experiment, learn and try out different type of ideas without any risk or cost. Okay. Now what is a EDA playground? What is EDA playground? EDA playground is a free web-based tool or a website that gives anyone access to professional expensive software for designing and testing digital hardware. Normally, to write and test VHDL or Verilog code, you would need to download and install massive complicated software programs from companies like Aldec or Cadence. These programs can cost thousands of dollars and are difficult to set up. So for that, EDA Playground solves this problem. It runs all these powerful tools on its own servers, so you can access them for free right from your web browser. All you need to do is write your code in the window, select a tool and click run. Okay. Now why do we use EDA Playground? This is the most important part or the most important question, that why shall we use this EDA Playground? Because it is 100% free. If you use your official mail account, means the mail account which is the mail which has been produced from your college or your any institute or any company, by using that mail ID only you can get all the commercial as well as non-commercial simulators for using or for doing code in the EDA Playground. Okay, so this is the one of the most important advantage, that it is 100% free. Another is no installation required. You don't need a powerful computer. You don't need to spend hours installing and configuring complex software, etc. You just open a website and it works. This is perfect for different institute from different college, university, etc. Okay. It is also easy to share, easy to save. You can share the link to your professor or your any classmate or any colleague that see, this is my code, I have done this, etc, etc. You can do from this. Okay, here you can learn by writing different type of codes in VHDL, Verilog, in different languages like Python, CPP. So these are all the advantage for using this EDA Playground. Okay, so this is the first discussion about what is EDA Playground, what are the advantages, what is the full form. Okay, so first let's focus on the biggest part of the screen. The two code windows, that are testbench.vhd and design.vhd. Think of the design.vhd file on the right. It is the blueprint of your actual hardware. This is where you describe the digital circuit you want to create. Okay, whether it's a simple AND gate or any kind of complex microprocessor, the VHDL or Verilog code that describes its inputs, outputs and logic goes right here. Okay, now Let's look at the testbench.vhd file on the left. If the design file is the blueprint for a car engine, then the test bench is the entire test track, the driver and the diagnostic system. The code you write here is not part of your final hardware. Okay? Its only job is to test your design. Here in this test bench, you will write code to generate input signals for your design, and then you will watch the outputs to make sure that the design is behaving exactly as you expect or not. Okay? So from this we can understand that design part is the blueprint part. Means here you design your code. It can be any simple AND gate or OR gate, anything. And it can also be some complex gate also, or complex microprocessor which you want to build by your own, and you have expected that this output will be generated on this code. For examine that, means for making it real or making it perfect or making it as true that yes, this output only generate from this design, for that perfection we use this test bench. This test bench just use to test your entire design part that it's working as you expected or not. So previously I have told you that test bench is not the actual hardware. Okay. So a question may arise that if the test bench is not the hardware, final hardware, then which one is the final hardware, or which function, or what is the thing that we can say that this is the final hardware? For this question, the answer is that is the design part is your final hardware. Because in the design part, you are doing all the things like what are the inputs will be have in your system or in your gate, or how many output will be generated from that. Again, what are the extra gates will be needed. All the things are done in the design part only. For just testing it, that the output which you have thought or think that this output will be generated by this design only, for that checking, for making it proof that yes, it is correct, we use the test bench part. Okay, so test bench part is just used for testing your code or testing your design whether it's working properly or not. Okay, so the final hardware, you can say the physical one, is the design. After that, for testing, test bench is used. Okay, so discussion on the code editor. The code editor, both the part design as well as test bench has been done. Okay, the explanation of the design and test bench has done. So now let's move towards the control panel, that is the present in the left sidebar. You can see it as it is present in the left side as a left sidebar. So this is one of the most important thing, because from here only you have to select each and everything in which you want to do code, in which you want to see the wave diagram, or etc etc. Means this is one of the important thing. This design part and test bench part is also important, but for writing any code, for writing your design, this left sidebar is also important. Okay, so let's discuss on this. Okay, now for the control panel on the left, this is where you configure your entire simulation environment. Okay, so at first let's break down the part that is languages and libraries. After breaking this section is where you tell the EDA Playground that what language you are writing in. Now this is the first part, that is the test bench plus design. Okay, this part here you can select from whole list of languages. As you can see, you can use VHDL, system Verilog, and even verification languages like Python or CPP. Okay, so for now I have selected the VHDL. As I have selected the VHDL, for that reason only the design part and the test bench part is holding a .vhd. Why? Because I have selected the VHDL. If I select it as a system Verilog or Verilog, then you can see that the test bench and design part has been changed from .vhd to .sv. Okay, in the same way, if I choose Python plus sv or Verilog, then you can see testbench.py, design.sv. In the same way, if I choose the cpp, then it will be so testbench.cpp and design.cpp. So it's your choice in which you want to do code. You have to choose that testbench plus design part. Okay, for now I am choosing the VHDL part. That's why it's showing as testbench.vhd and design.vhd. Let's move towards the libraries part. This libraries part lets you include pre-written standard code libraries for more advanced testing. Okay, so for now you can just leave this or you can set it as none. Okay, then the next part is top entity. This is super important. Okay, this simulator needs to know which part of your code to start running. You must put the name of your test bench entity in this box. If you leave it blank, the simulator won't know what to do and you will get an error. So this is one of the important part. The entity name which you will provide in the test bench, you have to give the same entity name in the top entity for running your code. After this, you can find a checkbox that is written as enable VUnit. So what is this? What is the meaning of this enable VUnit? So VUnit is a open source unit testing framework for VHDL. Think like that you have written a code and you have given a manual process to run, like run on this input 00, 01, 10, 11 in a specific order. Okay, but by enabling this VUnit test bench here, the structure would be different. Means the structure of your code will work or will be different. How? Instead of one big process, you would create multiple small independent test process. Okay, means that a process to test like 0 and 0, then another to test like 0 and 1, like this way. Think that why should we enable this, or what if we enable this VUnit? If you enable this, suppose you have enabled the VUnit, that means you are telling the VUnit library that please include the VUnit library which contains a lot of pre-written code for automatically finding and running test. Then what is the use of this VUnit runner? Instead of just running the test bench normally, which you will write as manually, it will use a VUnit special test runner to find all the individual test cases and run them, and it will give a clean pass or fail report in the log. So what do you think, that if you want, means if you have to enable this VUnit or not? I will suggest for now, means if you doing like basic AND gate or OR gate or anything basic type of things, then you should leave it unchecked, because VUnit is a very powerful tool used in professional large scale projects where you might have hundreds or thousands of teeny tests to manage. Okay, so for learning the basics of the VHDL or learning that how the VHDL work, how the simple gates work, the manual test bench are good. Okay, means write the manual test in the test bench, like 00, this input will be go, then what output will become. If 01 output goes, then what output will become. Like this way, the manually part will be good for now, for the basic. But for the advanced, where your system is very large and you need very much test to manage that whether it is working purely properly or not, in that case you can enable this VUnit or you can check this VUnit. Okay, So the languages and libraries part are completed. Let's move towards the tools and simulators part. So these tools and simulators is all about the simulation software itself. Now I am clicking on this arrow button. After clicking on this arrow button, you can see huge amount of different types of things are present, like commercial simulators, commercial synthesizers, etc. etc. So we can say this as EDA Playground gives you access to multiple professional grade simulators from companies like Aldec, Cadence and Synopsys. They all do the same basic job for running your code. Okay? Now you can see here that a huge amount of options are present. Your first question will be that they all do the same job. As I have told you earlier that they all do the same basic job of running. But make a point that I have told you they all do same basic job, that is running your code. Not that it gives you the same output or same thing. No, they do not do the same job. Their basic job is producing the output only. But they produce very different outputs. Means each and every part produce output only, but in different manner or in different language or in different type. Okay, so this list is a mix of tools for different purpose. The two most important categories for you to know are simulators and synthesizers. Now, what is simulators or what are the use of these simulators? These tools run your code, both the design and the test bench part, to show you how it behaves. What they do actually? They just simulate your design over time. They execute your test bench line by line, okay, and show you how your design responds. Means after choosing that any type of simulator, you can find a runtime present. In the runtime, you can make any time of waiting time, like wait for 10 seconds, then check next output. Again that after wait for 10 seconds, then check for next output. This is the process how the design will respond. Okay. For that example, means for that type of simulators like this Aldec Riviera-PRO, then Cadence, then Siemens, then Synopsys. These all are the commercial simulators. What is the output format? Means what is their output? Their output is a waveform and the console log. Means the output which is formed as a waveform, it give you a EPWave image will be sent or it will be shown to you as an output. And the console log where all tests are passed, it will appear here, and this thing are done by the simulators part. Now what does this synthesizer do? These tools build your final hardware. They only look at your design code, like this design.vhd you can see here. Okay, they cannot understand most test bench commands like wait or anything else. Means at first I told you now in the simulators part that wait for 10 seconds. If you do this, that means the output will generate by waiting 10 seconds. Means if you do like wait for 10 nanoseconds, then each output will produce by waiting after 10 nanoseconds. Means you have given two input 0 0, the output will be formed or will generate, then again it will wait for 10 nanoseconds, then again it will be moved towards the 0 1, in that way 1 0 and 1 1 like this. But in the synthesizer, it cannot understand most test bench commands like wait. Then what they do? They take your VHDL design code and translate it into a list of actual electronic components that can be put onto a physical chip. It basically translates it into a list of actual electronic components. It can be in form logic gates or any flip flops, anything. Okay. As an example, you can see here Aldec synthesizer, Siemens precision. These two are in the commercial synthesizer or fall into the commercial synthesizers. Then what is their output? Their output is a report telling you how many gates your design will use. Means, if I give an example that if you are doing an AND gate, then how many gate is need to do the AND gate? Your design will tell, or it will tell us your design uses one AND gate. Okay. After this, it will give a netlist file, means a blueprint for the file chip. They will give the blueprint of the final file chip, that yes, your design needs AND gate and this is the blueprint of your final chip. This is the AND gate. They will not produce any waveform. This is one of the most important thing. So the basic difference is simulators produce waveform, synthesizer do not produce any waveform. It produces the blueprint for that final chip. Okay. The other tools like this Python, CPP, etc. are for very advanced verification, where you might use a programming language to write an extremely complex test bench. So for now you can ignore this. Okay. I think that the most important difference you have understand that what is the difference between simulator, what is synthesizer, and what are these other tools are also mills like Python, CPP, etc, etc. Okay, so for now I am choosing the first commercial simulators, that is Aldec Riviera-PRO. After clicking that, you can find or you can see another option that is present as compile options. And in this compile option, some value is present, or you can see that is 20190. This part refers to the VHDL language standard version. Think of it like versions of a spoken language or a programming language. Just as there is Python 2 and Python 3, VHDL also has different versions with updated rules and new features. Like VHDL 93, it was the classic version. Then VHDL 2008, a major update with lots of new features was included in that part. Then now the new feature, that is VHDL 2019, the latest standard with more improvements. Okay, by putting this 2019 in the compile option, you are telling the simulator, please compile my code using the rules and features of the VHDL 2019 standard. Okay, and you can find a -o type, means -o is written, that is means as optimization. This -o part is a common flag in many compilers that stands for optimization. This is a general instruction to the tool to try and make the simulation run more efficiently or faster. Think that I have done a small design that is an AND gate, then it won't have any noticeable effect. Okay. So this is the meaning that why it is present as 2019 and then -o. Now let's move towards the run options. So for now let's ignore these run options, because these run options is basically used for the more detailed design or more complicated design. So for now let's ignore this. So let's move towards the runtime. This tells the simulator how long you want to, or how long you want the test to run. You can usually want to set this to something much shorter, like 200 nanosecond or 10 nanosecond, anything. But better ignore this runtime and use this runtime, means in the test bench part only you can write as wait 10 nanosecond. By writing that, you no need to write anything in the runtime. Okay, so this is all about runtime. Now these checkboxes, these all checkboxes which are present, 1 2 3 4 5 checkboxes are present. These are the most important. Okay, here you can see the most important one is the open EPWave after run. make sure this is always checked. This is the tool that opens the waveform viewer, allowing you to actually see your signals and debug your design. Okay. The show output file is also useful for seeing any message or errors printed by your test bench. Okay. So these two files are important. So the open EPWave after run, you have to always check in, and the optional is show output file after run. So for now or for your testing, always check or click on the box that is open EPWave after run. The last is the example part. So this is an incredible resource. If you are ever stuck or want to see how to code a special feature or specific feature, you can find a ton of working examples for VHDL, Verilog and more. Okay, so it's a great way to learn. So you can click any option from here and you can learn anything like how to use EDA Playground or VHDL. You can learn anything by clicking on VHDL, how to work on VHDL or how to work on Verilog. Anything you can click, anything you can learn by clicking on this. Some example will be shown to you. Okay, so this is all about example, tools and simulators and languages and libraries. So this left side part also completed. Let's move towards the upper part. In this upper part, you can see a box is written as new. If you click on this new button, then another new window will be open for your EDA Playground and you can do your code or different code in that. Okay, so this is the purpose of the new button. The next button is run. By clicking on this run button, you can run your code. You can see the errors, what are the errors are forming by your code. You can also see that whether the code has been compiled or not. Again, by clicking on this run button, you can also see the output also. Okay, so this is the use of this run button. Now the next is the save button. Here, by clicking on this save button, you can save your code in the EDA Playground website only. Okay, now let's move towards the right side upper part. Okay, so this resource button, the first button is the resources. In these resources, you can get many links for training, webinars, etc. Okay, after this, the community button. In this community button, you can collaborate with them. Okay, so this is the use of this community button. Next, help button. In this help button, you can send some requests, some pages or some comments which you need to edit. You can do from there. Next is playground. This playground button have two options. Your playgrounds. By clicking on this your playground, you can see your saved code. Whatever code you have saved, you can see from here. Like you can see, I have saved some gates like AND gate and OR gate. Both are present here. So by clicking on this your playgrounds, you can check or you can get your saved codes, all saved codes. Next is published playground. If you published your any code, you can check from here. Okay, after this, next section or next button is profile. In clicking, means if you click on this profile button, then you will go or directed to your profile on, where you can change or where you can see your all details like your college name, your first name, etc. Okay, so from here you can check your published playground and you can also check your saved playground also by clicking on this your playground. Okay, after this, you can see in the profile section another option is present, logout. So if you click on this logout button, after that you can see another option is present as logout in red color button. You have to click on that button also. After clicking this, you can see that you have logout from this EDA Playground website, and again you can relog in from this checkbox or login with Google or login from your official mail ID from which given from your institute or from company, etc. Okay, so in this video you have learned all the things about EDA Playground, that what is use of these, what is the use of this left sidebar, what is the use of the upper part, each and everything has been discussed and explained in this video. Okay, so this is all about the EDA Playground. Okay, thank you.